All right, so if you printed the notes, we're going to go a little bit out of order as far as how it's set up in terms of with inverse functions. I'm going to go through and we're going to talk about how to write the inverse of a function, and then we'll worry about showing if a function is, or if two functions are inverses of one another. So when we want to solve, or we want to actually find the inverse of a function, okay, what you're going to do, first off, it's most likely going to start off as f of x equals whatever, okay, whatever you have. And then what you'll do is you'll change it to y, okay, flip the x and the y value, so just the x and the y. The coefficient in front of either one does not change. Okay, only thing that's going to happen is just the x is going to go where the y was, the y is going to go where the x was, and then you're going to solve for y. Okay, it's going to be y equals, and then we can turn it back into the inverse of a function and how it should look there. So whenever we find the inverse, so if it's f of x equals 7x plus 5. So we can zoom, there we go. So if we have 7x minus 5, first off, it's going to be y equals 7x minus 5. Okay, so we just changed the f of x to a y. Now, second step is just going to be to flip your x and your y value. So whenever I flip it, I just worry about the x and the y. Bless you. It's going to be x equals 7y minus 5. Nothing else changes. Don't get in the habit. Don't move the 7x over here and the y there. It's just the x and the y flip places. And then now it just becomes solving an equation for y. So how are you going to get y by itself? What's the first thing I need to do? Add 5. So I'm going to add 5 to both sides. So add 5 to the left, add 5 to the right. I have x plus 5 equals 7y. Now, how am I going to get y by itself? Divide everything by 7. So x plus 5 over 7 equals y. Or you can write it as f to the negative 1 power of x. Okay, that's just how it looks when, is another way to write the inverse of a function. So the inverse of the original function is just f to the negative 1 power and then of x in the parentheses. I'm okay with you leaving it as x plus 5 over 7. If you want to write it as x over 7 plus 5 over 7, that's fine. But again, you can just leave it like this and that's completely alright. Okay, you can leave it as one big fraction. If things can cancel, then you'll cancel. But most likely, since it's going to start off as a function, it's just going to be y equals, then you're going to have most likely a 1 in front of your x. Same way if it is, f of x equals x to the third plus 1. So whenever we start off, we're going to have y equals x to the third plus 1. Switch the places, so I'm going to have x equals y to the third plus 1. Now just solve for y. So how am I going to get y by itself? What do I need to remove first from the right side? The 1. So subtract the 1 from both the left and the right and have x minus 1 equals y to the third. Now how am I going to get rid of the cube? Cube root. So I'm going to take the cube root of both sides. So when I take the cube root of both sides, the cube root and the cube go away. So I have the cube root of x minus 1 equals y. Or again, like we said, you can write it as f to the negative 1 power of x. And it's going to mean the same thing. Is nothing on 4 changes as far as how we start. We're still going to make it y equals 5 over x plus 4. Now, I need to flip the places of x and y. So it's going to be x equals 5 over y plus 4. So now I need to get this fraction, the 5 over y by itself. So how am I going to get rid of the 4? Just subtract it, right? So I'm going to subtract 4 from both sides and have x minus 4, bless you, over 5, or equal to 5 over y. Here's where you can kind of shortcut this. Okay? Where I have x minus 4 equal to 5 over y, anytime you have a variable in the denominator spot, okay? Anytime you have a variable in the denominator spot and it's equal to something that's a whole number, I mean it's x minus 4, it's a whole part over on the other side. What we're going to end up with, or what I can do, is take these two and switch places. So whenever I do that, my final answer is going to be y equals 5 over x minus 4. So what did I do? Okay, this is my final answer. Okay, and I'll show you why it works in a second. But if you get to this point, you can just flip the 2 right here and be done with it. Okay, because if I have y in the denominator spot, what do I need to do? What do I need to multiply the right side to get the y out of the denominator spot? How do I get the y off the bottom over here? I'm going to have to multiply it, right? So before, or what I would have had to have done here was multiply by y. So I have y times x minus 4 equal to 5. Now, would I want to actually distribute the y to everything inside here? No, that's a lot of extra work that we don't need to do. What would I divide by over here on the left side? The x minus 4. So where's that x minus 4 actually going to go? Yeah, it's going to be underneath anyway. Okay, so all I did was basically just eliminate this step right here. Whenever I divided by the x minus 4, those go away. That's the same thing as right here. Okay, so if you get to this point that's kind of highlighted in red, if you get to that point to where you have anything, it doesn't matter what it looks like. It could be 2x plus 7 equal to 6 over y. What's y going to equal? What am I going to do with these two values? Just switch the places. Okay, and it's just going to make it 6 over 2x plus 7. Whatever you have over here, I just have to make sure that I move the whole thing. Okay, so the whole thing on the left side needs to replace or change places with the whole part on the bottom side over here. Okay, you can do it this way. I have no issue in that with how we did it in kind of the long way, but just know that that shortcut is there. Okay, so if you know, hey, I've got y down here in the bottom side and I have a whole part over there on the left, I can just switch places. Now, it doesn't work that way if you have a fraction on one side and a fraction on the other. Then there are other things that you can do. But if you just have a single whole part, okay, and it could just be a 7, it could be whatever. Okay, it could be the 2x plus 7. But all you have to do with that denominator and that numerator is just switch places. Okay, that 6, like in the extra example, or that 5, that didn't change. That didn't go anywhere. It just stayed exactly where it was at. All we did was just change what was on the left side and replaced it, or just change positions with our denominator on the right side. Yesterday we talked about composition of functions. Okay, so to actually see if two functions are inverses of each other, one way to do it is to do a composition of each function. So to do f of g of x and g of f of x. So if we have two functions and we want to know if they're inverses of each other, I'm going to show you two different ways that you can do this so then you have options. It does not matter to me how you determine if they're inverses of one another. It's completely up to you. Okay, I'm just going to give you both options so that way you have two different chances to get this right. So the first way is just to do a composition of two functions. So I'm going to do f of g of x and g of f of x. And I'm just going to go with what we did yesterday. So if it's f of g of x, that just means that I'm going to take this part right here and replace it with the x that I have there. So 4 times x plus 7 over 4 minus 7. If they're going to be inverses of each other, both compositions have to be equal to x. Okay, everything has to cancel out and be x. Well, what's going to happen with the 4's right there? They're going to cancel. Okay, that's a good thing. So then I'm down to x plus 7 minus 7. What's going to happen to the plus 7 and the minus 7? It's going to cancel out. So then I am left with just an x. That's a good thing. Now I need to go in the reverse order and take it from f of x. So take the 4x minus 7 and plug it in for the x that I have over here. So I'm going to have 4x minus 7 plus 7 on top, all over 4. Now, whenever I have problems like this, this is where students get in way too big of a hurry. Remember, you just combine like terms. What's going to happen to the negative 7 and the positive 7?
0.
It's going to cancel or be 0. So those two go away. And then I'm down to 4x over 4. What's going to happen to the 4's? They go away. And I'm left with x. Again, if both compositions of each function, okay, so f into g and g into f, if they both basically cancel out to where they're equal to x, they are going to be inverses of each other. Okay, so that's one way. Your other way, I'll just kind of box it off here, is to just write the inverse of each function. So if I have f of x equals 4x minus 7, and I want to do the inverse, so if I have y equals 4x minus 7, change the x and the y, and solve for y. Add 7 to both sides, x plus 7 equals 4y. Divide by 4. So x plus 7 over 4 equals y. Does this match that? Yeah. Okay, so that's good. Now, it has to make sure that it works both ways. So I need to basically take the g of x function and do the same thing. So whenever I do, I'm going to take g of x, which is y equal to x plus 7 over 4, change the x and the y. How am I going to get rid of the 4? Just multiply it. So 4x equals y plus 7. Subtract 7. 4x minus 7 equals y. Does that look like this? Yeah. Okay. Basically what should happen is that one should look the same, that one should look the same. If that happens, then again, yes, they are inverses of each other. You don't have to do it both ways. You can either do the way on the left and do a composite function of each one, or you can just find the inverse of each function and see if it's where you started at for the other function. Okay? It does not matter to me. do what's ever easiest for you. I had students last year that said, I'd rather just find the inverse. Fine, find the inverse. Do it whichever way is going to be easier for you. I'm not going to tell you you have to do it this way. Okay? I'm just going to give you both options. Then, we already talked about this earlier as far as being one-to-one. And anytime it is an inverse, or anytime a function is one-to-one, then it's going to have an inverse. So for it to have an inverse, it has to be one-to-one. For it to be an inverse, that means it has to pass the horizontal line test. So does A pass the horizontal line test? No. It's right there. Does B pass the horizontal line test? Yes? C. And then C passes the horizontal line test. Okay? So then, like we've talked about already, 5A would not be one-to-one. 5B and 5C would be one-to-one. Okay, so if it's an inverse, if it passes the horizontal line test, then it's going to be one-to-one if it passes the vertical line test as well. Okay, if it's one-to-one, then that means the inverse will be a function. Okay, so that's a little bit of what you've already talked about and what you've already done. Basically, anytime you have a graph, notice that all you're going to do is just anytime you're just going to flip the x and the y values. Okay, the x becomes the y becomes the x. So you can find any point to see if it is going to be a function, or if the inverses as far as whenever we graph them. They may overlap, they may not, they may share the same point. It just depends on what kind of function we're dealing with.